time looking at two-way tables. And in a nutshell, there's just been a lot of different ways to describe data, whether it's in terms of mean, median, mode, or whether it's in terms of measure of center or a measure of variation. We talked about how to display all that stuff, like I've said. And today what we're going to kind of do is think about what we've done in the first 4 sections and talk about what we think would be the best type of chart or display for a given situation. And I'm going to kind of help you out with that today a little bit. One thing you're going to want to do in your notes today, or with your notes today, is this. I'm going to have you guys jump into big ideas. So why don't you guys make sure you're logged into big ideas.
And go to the assignment.
Well, not necessarily the assignment, John. Here's what I want to have you do today. We're going to talk about one of the assignments that's from your e-book, your online book. Really, it's like your hardcover book, but be important to get to that page here to start. So why don't you guys get logged in here first. And what I'd like you to do is to go to resources right here. Do you guys have an app tile that looks like this? It says Student Dynamic eBook.
Yep.
Right down here. Okay, why don't you click on that once you're in there, Student Dynamic eBook. And while it's loading up here, I think your screen is exactly the way mine is almost. I've got to click on my book here first. All right, is this what you guys kind of have in front of you right here? What I have? When you go, okay, your screen looks like mine right here. Okay, do you see this Contents tab up here? Everybody see this Contents tab up here? Click on Contents right up here in the bottom left, or top left, I mean. And scroll down to Chapter 7. Click the plus sign here on Chapter 7. And as I scroll down here a little bit, I just want you guys to click on 7.5. 7.5 right here. And that should take you to page 363. Is that happening right here?
Yep.
Okay. So what I want you guys to do is this. I want you to page ahead here a bit. I want you to page ahead to the one that says Example 2, which is page 300 and page 364 really is what, yeah, page 365, I'm sorry. Say page 365 up top here. That's where I want you to be for what we're going to discuss here in a bit. So make sure you're there on page 365 with me. You guys okay with that? Good there? Is there anybody not there at all? Are you getting there, Miriam? Okay, click Contents right up there. Yep. Perfect. You're there. Perfect. Okay. So just kind of leave that open, and in your notes, let's get started here. So, guys, 7.5 is titled Choosing a Data Display, and again, we've talked about a ton of them. And what we want to know is the following. How can you display data in a way that helps you make decisions? In other words, here's a bunch of data. How could you put that in some type of a chart to be able to make some decisions about your data? And, you know, what do you want to know about your data? So in order to answer that question today, we need to be able to classify data as 2 words that are going to stick out today. Quantitative or qualitative. We're going to want to look at choosing and creating appropriate data displays. And then we're going to talk about analyzing what's called a misleading graph. And again, this is going to be pretty simple, I think. All right. So let's get started here with this. First vocab word right here, qualitative data. I have a volunteer that would read my definition for qualitative data. Who wants this one right here? Qualitative data is our first vocab word. We need to make sure we understand. John, you want it?
Mm-hmm.
Thank you.
All right. Was it qualitative data?
Yep, qualitative data.
Labels are non-numerical entries that can be used for identification purposes.
Identification purposes. So sometimes we use numbers to say, hey, we want to be able to identify somebody, or we want to be able to use it as a label, if you will. An example that I gave you, the example that I'm giving you of a qualitative data piece is numbers that are on a license plate. Those numbers on a license plate kind of identify who you are. Okay. How about this? Every time I apply for a bank loan, guess what number they want from me? They want my social security number. Does that social security number identify who I am? How about this? I have a cell phone. Okay. They always ask you for your cell phone number when you want to ask questions. Okay. So those types of numbers, anytime you're identifying somebody or labeling something, that's going to be considered some type of qualitative data. The kids that play basketball out there, they all wear a uniform, right? And on those uniforms, there is a number. That number identifies or labels who they are, okay? So if a number is identifying somebody or labeling somebody, that's going to be considered qualitative data, okay? Now, quantitative data right here is a bit different. Quantitative data is data that can be counted or measured. So if I ask you this question, how many kids are in this class right now? Is that a label or an identification, or am I actually counting to measure to know how many people are in here? I'm counting the number of people in here. So anytime you're counting something or measuring something, that's going to be considered quantitative data. All right? Quantitative data. Data that can be counted or measured. An example right here. If I want to measure the length of a basketball court, if I'm measuring something, that's considered what type of data? What type of data if you can measure or count it? Okay, so the things I think you should highlight here are the following. Qualitative data either labels or identifies something. Okay? Quantitative data is anything that can be counted or measured. If you can count it or measure it, then that's considered quantitative. Okay? And then the last term that we need to understand or know about before we start looking at is called a misleading graph. Okay, misleading graph. And a misleading graph is a statistical graph that is not drawn appropriately. Okay? Guys, there's some kind of thing coming up in November. Something pretty important going on in November. What's going on that's important in November? An election. Two primary parties in the election are the Republicans and the Democrats. Do you think one of those parties wants to start putting displays out about some of the issues that are important to them that make them look good?
Yeah.
They're going to want to put charts and stuff out that make them look good. Now, if numbers are pretty close, do you think those parties are going to try and change that graph so it makes them look better, or are they just going to go with the way it actually is? Yeah, politicians, they're all liars, right? Every single one of them is a liar. Well, I think they are. You guys might think that, don't you? Okay, politicians are going to make things look good. So sometimes they might lead you into thinking something different by presenting you with a misleading graph, something that's not drawn appropriately. They're trying to change your mind on stuff. Okay, so they use misleading graphs. Okay, hey, give me a second here. Guys, I'm going to type this in. See if I can make this work. Guys, remember the meta chart we were using the other day? You guys remember that? Oh, I hope it works. Okay, meta chart right here. Guys, MetaChart was a nice tool that we used to be able to put some of our information in and create a graph. Now again, we had to come up with the information to make this work. But today what we're talking about is many types of graphs. And I'm just going to kind of use this home page as a tool for us to remember things. But down below in your notes right here, I want to kind of make the connection between what's in the wording and what's in the visual right here for you. Yeah. If you're in MetaChart in a histogram maker that you bookmarked already, if you click that home button in the top left, that'll give you all those charts here as a visual.
Which home button?
The home button on the website, which says home right here, John.
Oh.
That makes sense to you, buddy?
Yes.
Okay. Gosh, I got to playing around with this the other day with more stuff, and this is a pretty sweet little site in terms of some of the things that we're going to look at doing down the road. So we're not going to completely get rid of this. This is pretty cool.
What's the website?
Metachart, meta-chart.com. Let's see if that takes you there, Andrew. I think you were gone that day, weren't you? Or were you here? I don't remember. Are you there, bud?
Yeah.
Okay. So, guys, in your notes, I just want you to understand something. I've kind of provided you a toolbox about some of the displays we're going to talk about that talk about this qualitative or quantitative data that we're trying to work with. And just to make some connections right here. My first type of data display that I'm discussing is a what here? What's it say? Bar graph. It says use a bar graph when showing data by what? Categories. So I'm going to go back to my chart here. Here's a bar graph right over here. A bar graph. Okay. The height of the bars give you the frequency, how many of something is there. But this orange here might represent the number of people that like the Syracuse Orange Men. All right. Then this blue bar right in here for bar chart or bar graph, if you will, they might represent the number of people that like the Duke Blue Devils. And then green. Oh. Maybe the University of Alabama, Birmingham. I don't even know what their last name is. All right, and then purple. I don't know what college is purple. Oh, the one right up the road here from us. This might be the number of people that are UNI fans or something like that. Okay. A bar graph is going to label things by category. So these determine what the frequency is in a certain category. Okay. All right. Histogram. We just got done working with histogram. It says histogram is a bar graph that really shows data visually, but the key term here is what, guys? How do they show that data? In intervals, right? You guys remember the last question on your take-home quiz? Didn't it say to draw a frequency table? And I think the first interval was from 11 to 30, and you had to count the dollar amounts at a gas pump and make a bar for that. Okay, so a histogram is basically a bar graph, but they show data in what's important right here, guys. In what?
Intervals.
Intervals, okay. And I'm going to highlight the parts that are important. Bar graph. When a bar graph is used, you're using data by showing the categories. Which categories are you representing? Okay. Frequency table. We know what a frequency table is.
I forgot what it was.
I'm going to show you right here, John.
Okay.
Frequency table right here. Do you see where it says, let's see. You see where it says maybe tally chart right here?
Yes.
It's basically a tally mark right here. A frequency table is basically the same thing as a tally chart. You're saying how many 40s did you have? And then we go 5, 10, 15, 20, 25, 30, 35, 40 of them, okay?
Okay.
So a tally chart basically tells you how many numbers fall in the interval. Instead of doing it in a graph form, they do it numerically. They put a number in there for you. Okay? They put a number in there for you. All right. Next one, line graph. I would hope we know what a line graph is. But a line graph is going to be any graph that shows a trend over time. Okay? Trend over time. So let me show you this right here. A line graph. Here's a line chart right here. You guys see this line chart right here? Everybody see your line graph right here? This is basically going to be a chart, but typically down here, guys, they're going to say, you know what, this is a chart where some kind of time is being represented down here. You might have days, you might have weeks, you might have hours, you might have seconds, but it's just going to show you a change over time. So if you're ever measuring something and like hours or minutes or days or weeks is one of your two labels, anytime you measure something over time, a line graph is probably your best display. Okay? All right, a couple other things then. Circle graph. Circle graph is going to show parts to whole using what? Percentages. Okay? We haven't talked much about a circle graph at all. Haven't talked much about a circle graph at all, but a quick image of it right here. Pie and bar charts. I don't know if you guys can see that very well, maybe on your screen, but right here, all of these sections are measured off by a certain percentage in your pie chart. Okay, so pie charts are going to use percentages of each category. And then the last one that they talk about here, guys, is box and whisker plots. And the big idea behind box and whisker plots is that we show data how, guys? In quartiles. We break them up into how many sections? 4 of them, right? We have a lower quartile, we have a middle half, and then finally we have the upper quartile. Okay. So these are all going to be types of data displays. I think that the words that I've highlighted right there should help you in determining which chart would be best as a display for some of the problems you're going to see today. And we'll look at some examples like that here in a second. But those are some types of data displays that we've discussed so far in this whole chapter. All right. So vocab and kind of a cheat sheet for types of data displays. Are you guys okay with this? There's nothing really new in these types of data displays. Would you guys agree? All right. So, guys, we're going to run on to page 2 right here. Page 2 is going to talk about qualitative data and quantitative data. Again, qualitative labels something or it identifies it. Quantitative data is something you're going to be able to count or what? Measure. So let's look at the second page of our notes here. Let's get going with some of the examples in terms of our goals that we want to accomplish. So example 1 says, hey, let's classify some data. We want to tell if something is either qualitative or quantitative. Okay, so I'm going to make the note right up here. Qualitative is either a label or an identification, and quantitative is something that you can either count or measure based on our definitions. So, here's the deal. You're in science class, and it says you measure the heights of some plants in an experiment. You're measuring heights of a plant in an experiment. Okay, so do you count the heights or do you measure the heights? You measure the heights. Are we labeling or identifying, or are we counting or measuring? Counting or measuring. So if I'm in a science class and we're writing down the heights of an experiment, is that some kind of quantitative or qualitative data that we're writing down? It's quantitative because we are measuring it. Since you are measuring it, you have to measure this. And since you have to measure this right here, this makes this type of data quantitative. Right, that makes that kind of data quantitative. I think I kind of gave away part B already as an example or definition, but hey, there goes 616 JAP. 616 JAP on my truck. That's a license plate number. Does that identify me or does that measure me? Identifies me. So this is used as some kind of identification. This is used as an ID. So is the type of data on a license plate, is the type of numerical data on a license plate qualitative or quantitative? It's going to be qualitative. Okay. Number of hours worked each this should say day. Number of hours worked each. Screwed that up. This should be each day. Number of hours worked each day. Counting the hours, right? You're counting the hours. It's a count. So what kind of data does that make? Makes this quantitative. Count. Types of flowers in a bouquet. We have type 1, type 2, type 3, type 4, type 5, type 6, type 7. We're labeling them, right? It's a type of flower. So anytime you have a type of something, you're labeling it. You're labeling that flower. So if this is labeled, if this is a label, qualitative or quantitative? This would be qualitative. Okay, very good. Very good. So if I ask you if something's quantitative or qualitative, can you handle it?
Yes.
Are we good? Okay. All right, so let's run into example 2. Now, example 2 is where we kind of start talking about choosing and creating a data display. Which of those data displays would be best to use in this situation? So I want to go to that page 365 in your dynamic ebook, and I want to kind of discuss example 2. I really want to discuss example 2 on page 365, so let me get there quickly. Oops. Any questions so far, guys? Anybody have any questions so far? Anybody? Okay. All right, so just want to kind of read through this in terms of what's going on, but example 2 talks about choosing and creating a data display. And you guys should have this in your Chromebooks as well, and I'll zoom up a bit so we can read this better up here. One more. That's as far as I can go, huh? All right, choosing and creating a data display. It says analyze the data and then create a data display that best represents the data. Explain your reasoning. So right here we have eye color survey. Over here in the left column it talks about the color of eyes that a sample size had and then how many or how frequently those occurred. So as I read this right here, blue eyes. How many people have blue eyes in that? 37. Okay. Now, are we showing this data in intervals? Are we showing it as a trend over time? Are we showing it in categories? How is that data represented? Brown, blue, hazel, green, gray, amber. Those would be some kind of a category, wouldn't they? Those would be some kind of a category. Now, in this one here, right here, guys, they suggest a solution. They say, a circle graph is one appropriate way to display the qualitative data. It shows parts of a whole. All right? Well, they're going to go ahead and turn these into percentages. They're going to total this whole thing up right here in the eye color survey, and they're going to turn all that stuff into a percentage, and then they break those percentages out, and they put that into a circle graph. Now, again, I'll have you read through some of this stuff in terms of how they come up with angles. I'm not too concerned about how they do that. But just understand right here, the categories are listed in the chart. Brown, blue, hazel. Guys, in this chart right here, why is the sector that's labeled brown, why is that sector bigger than every other sector in this pie graph? Yeah. Brown eyes had the highest value, right? Okay. Now, another way that you could have maybe done this, again, we're talking about doing an eye color survey in categories here, right? If you go back to my notes on the first page right here, I also said another way to display data by categories would have been what else? A bar graph. I could have put all those colors in a bar graph. I could have had brown and had a bar go up to 63. And then blue and had a bar go up to 37. So is a pie graph the only option there according to example 2? No. So I want you to understand, sometimes data displays might have multiple options depending upon its situation. Okay? Make sense, everybody? So you might want to be referring to this chart here as we go through some examples. Back here, guys, right here, they talk about example B right here. Anytime you make a comparison between two types of data right here, we have some data for interstate A and a data for interstate B. Typically for this right here, if you ever are making comparisons from one data set to another data set, what did they use for this in part B? They're talking about all the speeds on one interstate over here and the speeds of cars on another interstate over here. So how many interstates am I talking about? How many interstates do we have data for in it? 2 of them. Okay? So right up here, when they say, hey, here's a table for the speeds of vehicles, interstate A and interstate B, all the speeds listed for interstate A, all the speeds listed for interstate B, they want to make a comparison of those 2 data charts. Well, we've looked in the past at having 2 different data charts listed comparably as what type of a chart, guys? Box and whisker plot. And part B says the following. It says a double box and whisker plot is one appropriate way to display this quantitative data. We use the 5-number summary of each data set to create what we call a double box and whisker plot. So typically when you're comparing 2 sets of data like that, you're going to have some kind of a double graph. In this case, double box and whisker plot. All right. So I just kind of want to touch on that there. You know how to get to page 365 if you need to read through that again. But I want to see what we have as examples to try and talk about. So on page 3 of your notes, here's the deal. We have part B right here, and I think I labeled this for you already down here, didn't I?
Yep.
Okay, what's it say down here at the bottom? Does it say week or weeks? Okay, so week.
And then along the side it says number of miles.
And it's number of miles over here?
Yep.
All right, I don't know if I labeled the heights of those. If I did not, I apologize. Did I go 1 through 15 up the side at all? No, I did 1 through 5 on the bottom, didn't I? So you might want to put 1, 2, 3, 4. Okay, so this is what the chart might look like. So it says analyze the data and then create a data display that represents the data and explain your reasoning. First of all, we're talking about the number of miles you walk. So in week 1, oh my gosh, week 1, how many miles did you walk? 5. In week 2, how long? Week 3. Week 4. How long was a week? How long was a week? 7 days. How long was a day? 24 hours. How long is an hour? All these questions I'm asking you relate to what? Time. We're showing data over what? Time. So if I go back to the front sheet and I say, hey, what's probably the best display for showing some kind of data over a time change? What's it say? Line graph. Yeah, line graph. We're gonna construct a line graph for this situation, and your reason is, well, weeks is some sort of a time frame. We're gonna go line graph because we are talking about change over what, kids? Change over time. Anytime you have some kind of a table where it addresses a change over maybe a time, you typically use a line graph for that. So let's just go ahead and plot this and see what this looks like. Week 1, how many miles did you walk? 5. So this is basically like going to the point. Right 1 and up 5 and plotting this point. Boom. Week 2, how far did you walk? 8 miles. So go to the point 2, 8. Three weeks, how far have you gone? How many miles did you walk in week 4?
11.
Okay, and that's all we account for, right? Guys, line graphs are great about showing trends over time. So if I would go ahead and connect my lines right here like this, I'll try my hardest. What's happening to your data over time? What's happening to the number of miles walked over time? Can you identify a trend in this? Look at the graph. Yeah, number of miles I walk each week looks like it's increasing. So anytime you're showing some type of data over time, you're probably going to want to consider a line graph, okay? Probably consider it to be a line graph. So let me do a better job of drawing that line here.
Is it supposed to be straight or kind of?
It's going to be curved. It should look more like this. I had the wrong tool open, so it should look like this, Taryn. Does that look a little better to you? Okay, kind of something like that. All right, very good. Next one says it's a table for a fruit survey. It says maybe at the lunch line, kids have to choose a fruit, and then this tells you how many they chose. Okay. So am I showing data over time? Am I showing data by categories? Am I showing 2 sets of data that we're trying to compare? this, guys? Apple, banana, grape, orange, pear. What is that? If I go back to the front page of the notes, what one highlighted word? Are they quartiles? No. Percentages? No. Time? No. There's some kind of a category, right? So if there's some kind of a category, all those fruits, what type of graph does this recommend? Bar graph. So let's do that quickly.
I could go with a candy bar right now.
I could go for a candy bar right now too, because I'm not me when I don't have my Snickers.
I'm not me when I don't have Milky Way or Three Musketeers.
John, you're just not gonna go Marsha, Marsha, Marsha on me, right? Have you seen that commercial?
I think so.
Marsha, Marsha, Marsha. I think it's so funny that Steve Buscemi is the guy saying Marsha, Marsha, Marsha.
Steve Machete.
Steve Machete. I haven't heard it like that before. That's a good one.
Okay.
No, Steve Buscemi is his name.
Oh, Machete. Sounds
Okay.
a lot like Machete.
All right, so let's put our fruits down at the bottom here, guys. Our first category is going to be an apple. They say an apple away keeps the doctor away. All right. Next one here would be. I'm going to put it right down here. I'm going to kind of use 2 bars for this right here, okay, guys? Next one would be from here to here. All right, the Minions. Anybody seen the Minion movie at all? They like to say what in that movie? Bananas, right?
I actually like the Minions. They're
Oh,
hilarious.
they're great, aren't they?
Oh, yes, they're hilarious.
Put banana there.
We're using 2 to 2.
Yeah, I'm gonna use two intervals for it. Okay, I'll show you here in a second what it looks like. Next one here, let's go grapes, and then oranges, and then pears. Pears. Anybody eat pears? Pears. Okay, so I'm going to label this over here. I'm going to get a good chart that looks like 40, so I'm going to go by tens on this, okay? 10, 20, 30, 40, all the way up to 50. Okay, so how many apples were there, kiddos? How many apples were consumed that day? 35. So I'm just going to go up to about 35. Draw my bar. Guys okay with that?
Yep.
Okay, next one. Bananas. 40 of them. Grapes was 15. Oranges was 28, so pretty darn close to 30 right here maybe. And then finally we had pears, which was how much? Was that 12? So there's 10, so 12 would be right about here. Quick question, guys, while you're finishing up your graphs, is that an accurate way to display that data from that table? Okay, and the reason we chose bar graph here is because we're showing data by, what are these down here called again? These are my categories right here. These are my categories. Okay, those are my categories. All right, so I'll wait till you have that drawn. We'll get this last page taken care of, which will take a short amount of time. And again, like I said, you guys have worked really hard for me for 2 whole weeks after Christmas break. So I'm encouraging you guys to take a 3-day weekend. So make sure you take Monday off, okay? Yeah.
I have a question.
Yeah, Andrew.
Okay, there was a thing on Facebook about people smuggling drugs and carrots. How would you do that?
Oh, yeah, I saw something like that. I don't know.
Actually,
I don't know.
guys have been doing it for a long time. They would hollow out the carrots, and then they would have the carrot top, and they would just place it back on. It wouldn't let
There
it
you go.
burn there.
Huh, very difficult.
That's what I thought. A lot of work.
Actually, they've been doing it
A lot of work for jail time, huh?
Very simple, hollow out a carrot.
All right, last page here. Last part I want to talk about, guys, analyzing misleading graphs. Misleading graphs happen pretty much in 2 ways. Typically, they're related to a line graph or a bar graph. 99% of the time, they're related to a bar graph or a line graph. The two examples I'm going to provide you with, bar graph, all right? This talks about the massive increase in prices this year. Now, if I look at this graph right here, the green bar to the orange bar, does it look like stuff jumped quite a bit? Does it look like stuff jumped quite a bit?
Yeah.
Okay. I'm going to do this right down here. Really, this value down here is 0. What we do is we kind of consider a break in the graph. Basically, misleading graphs occur two ways. One way is this. When you jump from 0 to the first value, how much of a gap is here from 0 up to 80,000? 80,000. It's all of it, isn't it? Okay. So really, this bar is actually pretty tall, even though it looks really short. Okay. It jumps by 80,000, and then all of a sudden it starts going up by thousands. So really, what's the price of the house in 98, guys? What's the price of a house in 1998? Average-wise, what's it say?
80,000.
And then what is it in 1999? 82,000. Okay, it only went up $2,000. Okay, it went up 2.5%. But this makes it look like the price of houses tripled the way the graph is presented. 2.5% is not tripling stuff, folks. Okay, so one way graphs are misleading is they have a big jump to start, or maybe there's a break in the graph.
What does DR stand for?
That should be an or, I'm sorry, John.
Okay.
Or a break in the graph. But it stands for doctor, if you want to know the answer. Good thing I didn't put pepper after that, right?
Yep.
That's calling Forrest Gump.
Or,
All right, and then another one, guys. Just a quick look at this right here. Can anybody identify why the second graph here is misleading? Starts at what? Starts at 75. It doesn't even start 0. It starts at what?
75.
So if stuff doesn't start at the beginning or 0 right here, sometimes if the start, if it starts at 75, it's not really starting from the lowest score, 0. Okay, so it starts at a funny value, if you will. Okay. All right, guys. The only thing I'm requiring you to get done over this section is the 7.5. You guys have confirmed that that's been sent out already, right? And take-home quiz corrections. When do I want those by? Tuesday. So any corrections you need to make by Tuesday. Put your corrections on a different sheet of paper. We'll staple those and turn them in by Tuesday. So don't forget if you're going to do that. Last reminder, again, everything, I put those new quiz scores in. Definitely check your JMC. Find out where you're at. Boy, I can't think of anything else. Mrs. Olson, can you think of anything I'm missing? Okay. Stay with it, guys. Stay with it. These are the dog days of the school year. These are tough times of the year in the winter time, right after break. So keep doing an excellent job like you have been doing. And again, I'd always encourage you. Quick quizzes. If you need to make corrections, do that. If you have questions, get in here and ask. Okay? Good to go, gang?
Yep.
All right. You guys enjoy your 3-day weekend, all right?